Okay, hello everybody. For today, I'm going to be reviewing area of a sector and arc length. You're going to be doing 2 of these problems, which will have 4 answers. And then I'm going to just be showing you how to find the area of a segment. And I'm not going to expect you to do it. So let's take a look here. For area of a sector, which is this part, that is if n is equal to the central angle, the area of a sector is whatever the central angle is divided by 360 times the area of a sector is pi r squared. Now, to find the arc length, which is this segment right here, this part, let me highlight that. So it's how much of the circumference do I have? So for arc length, I think I said area of segment. So for arc length, it is the central angle divided by 360 times the formula for circumference, which is 2 pi r. So if you notice here, we have 2 variables. We have n, which is the central angle, and we have r, which is the radius. So this is my n, this is my r. So it's just a matter of plugging those in. So for the area of the sector, for both of these, the central angle is 90, so I put that over 360. And for area, it's pi r squared, so it's going to be pi 12 squared. And then for arc length, I'm going to put the same 90 degrees in the numerator over 360. And then instead of pi r squared, I have 2 pi r, which is 2 pi 12, because that's the formula for circumference. So when I put those into my calculator, I end up with 36 pi for area, and I end up with 6 pi for the arc length. Whoops, down here. What am I doing? Right here. 6 pi. So area means how much fits on the surface of something, and arc length means how much of the circumference do I have. So you're going to do those for these 2 problems. Just remember, follow these formulas. For the area, it's the central angle over 360 times pi r squared, which is the formula for the area of a circle. And for the arc length, it's the central angle over 360 times 2 pi r. And you'll do that for this one, and you'll do that for this one. And everything is given for you. So let's take a look here. We've talked about arc length. We've talked about area of a sector, but we haven't talked about segment. And so I want to talk to you about what that means. There's a lot of steps involved in doing the area of a segment. So if I'm going to find the area of a segment, first I start with a circle. Obviously, I need the center of the circle. I need to know what is the radius. I need to know the central angle. I'm going to call that n. But the difference is I'm going to have a chord. A chord is a line segment that goes from the edge of the circle to the edge of the circle, but it's not going through the center, so it's not a radius or a diameter. And what it does is it breaks this into 2 parts. it takes and gives me this little bit right here. But I also see that I have like a little triangle right here. Now I know how to find the area of a triangle. And I know how to find the area of a segment, or of a sector. So if I were to take this bit out of there, I can find the area of the sector. Then, if I take away that triangle, and I find the area of just the triangle, all that would leave me is this little bit right here. So I would have that little piece left, which is the area of the segment. It's a lot of steps. So let me do an example for you. So if I have a circle, and I have a central angle of 30 and I have a radius of 10. So the first thing I'm going to do is the area of the sector, which is n over 360 times pi r squared. Then I want to subtract the area of that triangle. Well, we did not get to this in our trigonometry unit, but there is a formula for finding the area of a non-right triangle if I have side, angle, side. So if I have this side and this angle and this side, I can use a trigonometric formula to find the area of that triangle. And that formula is AB sine of C divided by 2. So the sides are A and B. The sine of the angle would be this n. So it's really going to be, for our purposes, we're going to say these are the radius, or the radii, right? So we're going to say r times the sine of our angle n divided by 2. So r times the sine of the central angle divided by 2, and that's going to give us the area of the segment. So let's do this one. It's just a lot of work. It's a lot of work. So I need n, which is the central angle. So 30 over 360 times pi 10 squared. For this part, I need the radius times the radius, because we know they're all the same. So 10 times the sine of the central angle, which is 30, divided by 2, and that's going to give me the area of the segment. So let's do each step here. So I have 30, whoopsie, N over D button, 30 pi 10 squared. What is going on? 30 pi 10 squared all over 360. 25 pi over 3. Now I'm going to do this part. N over D button. 10 times the sine of 30 all over 2. And I get 25. So now I'm going to take this and I'm going to subtract that. So N over D button. 25 pi over 3, come out of that denominator, minus 25, and I get 1.17, and on and on and on. So that's how you find the area of a segment. It takes a lot of time. I'll do one more just so that you have experience with these, but we're not going to do them, and I'm going to use this space down here. So here's what I have. So I'm going to have n over 360 times pi r squared minus r times the sine of the n degrees over 2, and that's going to give me my answer. So this is my r, this is my n. I also have radius times the radius right here. So let's take a look at that. That's going to be 60 over 360 times pi 4 squared minus 4 times 4 times the sine of 60 over 2. And it's going to give me my answer. And I can do the whole thing in the calculator at one time, as long as I'm careful, which it doesn't seem like I am this morning. So let's try this. 60 pi 4 squared over 360. Come out of the denominator, minus 4 times the sine of 60. Oh geez, I didn't push the N over D button. Okay. 4 times the sine of 60 divided by 2. When I push enter, I get 1.449. So, that's how you find the area of a segment. Do you have to find the area of a segment? No. You're going to do these two problems. So this will be numbers 1, 2, 3, and 4. The first 1 and 3 are area. 2 and 4 are arc length. Here's your formulas. Write it down and enjoy the rest of your day.